All right. Here we go. Think like a hacker. Looking forward to this one too. Hacking Laravel at the Laravel conference. Oops, he's coming. I think. There we go. There it is.
Okay, am I in?
You're in.
Awesome.
Perfect.
Okay, let me get my screen share up and running. Cool.
You're good.
How's that look?
You're good. Take it away.
Awesome. Okay, so what does think like a hacker mean? Well, it's about the mindset. It's about how you think about the security, how you think about how you protect yourself and you protect your sites. And so when you're trying to secure your applications, the sites that you're building, the applications that you're working on, you don't just go find a checklist on the internet that has a bunch of security things. There's a good chance that it'll have some things on it that make no sense whatsoever for your application, because it's written by someone who generally has worked on their own applications and they know what things they needed to secure for their sites, but it might not be things that are relevant to yours. So consider, for example, that they might have, secure your S3 buckets, or make sure that your external databases are all password protected. Make sure that, I don't know, that the forums, the data is properly, the user input is properly escaped, but you're still allowing through various tags and that sort of thing. So you could have a bunch of things like that, but your application might not do any of those at all. And if it doesn't do any of those things, then following the checklist is pointless, because there's a bunch of tasks on there that don't actually relate to your application. And so you need to look at what your site does and the ways that your site could be vulnerable in order to secure it properly. So for example, if you have a file upload feature, you need to think about, what types of files are allowed to be uploaded, who can upload the files, where they get stored, can they be accessed directly? But also, if someone does manage to access the file directly, what can they do? What can it access? Can it get to other applications on the server? That sort of thing. So there's a whole bunch of things you need to think about if you do file uploads. If you don't do file uploads, you don't have to prioritize those. You don't have to think about most of those. There's still some of the low-level things that you would need to think about for different vulnerabilities and different ways that the attacker could get in, but they're a different priority as opposed to a site that does file uploads. So what we're going to do today is something a bit different. We're going to break into a specifically vulnerable and intentionally vulnerable Laravel application. And we're going to look at the ways a hacker would break into this site and look at how to defend against it, to give you an idea of how to look at your application. So you can go back to your code and your work, your applications, and go, okay, so looking at this feature, what would an attacker do? How would an attacker try to break into this application? And then you know where to focus and what to secure better. So this is our application and we're going to be the hacker. So the first thing we do as the hacker when we get to our site is we're going to look for what features and functionality it has and things like a login form. Because if we can log in, then it gives us the ability to try and hijack a user account. Because if we can break into someone's account, ideally an administrator, then we have access to the system. We could have access to their personal information, or if they're an admin, we could have access to admin tools. So as a hacker, how do we break into someone's accounts? Well, we can take advantage of the biggest vulnerability that a web application has, and that is the user, the person sitting on the chair in front of the keyboard. And so we can do that because people are lazy. So imagine that you've got a user and they've signed up for 3 different sites. Now, because they're lazy, they're going to reuse the same password on all 3 sites. So if they've used their password over here, they're likely to use it here and here. If we, as the hacker or some other hacker, can break into the site over here and the passwords are stored in plain text, then we gain a list of email addresses or usernames and passwords that work. And if we have those combinations, then we have the login details for this site and this site too. And so we can try those credentials, those login details on the other sites to try and break into them. So where's it gone? So this is my little credential stuffing list that has been stolen from a site, right? And what we're going to do is we're going to work through the list and see if we can identify any valid users on this site and try and log in as them. So we'll grab the first user, who's bilbo@baggins.com, jump back over to the site. Now we could try and log in straight away with these credentials, but that could raise some alerts. It could set off some rate limiting, that sort of thing. There could be brute force detections in place on the login form. So instead, we're going to go to the registration form and we're going to cheat in here, because often when a site accepts unique email addresses, you can use the registration form as an enumeration vulnerability to identify if the user exists. And this might not trigger rate limiting or any sort of other alerting. So through random passwords that don't match and the email address you want to check and go register. This gives us the error message, this email has already been taken. So we know this is a valid user on the site. We can now go to the login form with their email address, back to our credential stuffing list, grab the password, paste it in. Okay, so those credentials don't work. So Bilbo has a different password to the one we know. What if we try Frodo? Give Frodo a try, back to the registration form, random passwords. There's no error message. So we know Frodo doesn't have an account, which means we don't have to bother trying to log in as Frodo. And it saves us hitting that login form this time because we know it's not going to work. Now we work through the list and we'll eventually get to this one, Stephen@valoran.dev. And we could try that in registration and we would see that they have an account. We go to the email address thing, we grab the password in here, paste it in, log in. We're now logged in. So Stephen@valoran.dev reused their password on multiple sites. And the best bit for us is Stephen@valoran.dev was an administrator. So we're now administrator on this site because we had their password, because they reused it on a different website. And that happens all the time. And now that we're an admin, we can do whatever we want. We can create our own admin accounts. We can change settings. We can access personal information. It's basically game over, which from an attacker, from a hacker's point of view, is exactly what we want. So how do you defend against this sort of an attack? And there are two things that I want to talk about, although there are lots of different options. But the first one is from a personal point of view, how do you protect your account when you're logging into sites? And you use what's called a password manager. So I recommend 1Password. It's the one I use and it's installed on all my different devices and it syncs my passwords. And the way it works is that it stores all my passwords, my usernames and my passwords and everything else in one application. Then all I have to remember is the password for 1Password. So when I want to log into a site, I go to 1Password, the browser extension, and I type my password into it and it fills in the login form and it lets me log in. And it makes it really easy to have a unique password on every single site because 1Password remembers it for me. Now, password managers all work in the same sort of way. And there are lots of different options. So you've got OnePass, LastPass, NPass, Dashlane. There's a bunch of open source options. It depends on what your needs are and what level you want to use. And also browsers have password managers built into them too. So Chrome has got one, Edge has one, Safari, I believe, has got one. I assume so. Firefox has one. And so you don't even need to pay for a third-party tool like 1Password. You could just use the one in the browser and that will still protect you because then something else is remembering the password for you and it's keeping it secure. But you can't force your users to use a password manager. No matter how much you try to remind them and tell them, they're not all going to do it. Some of them will be too lazy. And we're back to the lazy point of view. Some of them just won't know how to do it. So instead, we need to use something like Pwned Passwords list. So Pwned Passwords is a project from Have I Been Pwned, where it's a list of real-world breached passwords that have been seen in data breaches. And these are passwords that are known and passwords that will be used when someone is trying to break into an account, often from a credential stuffing list or just from a brute force list. And you can use Pwned Passwords to check if the password has been seen before. So if I type in the password for Stephen@valoran.dev that we had before and ask it, it's going to tell us that it's been seen, it's been pwned over 40,000 times. So this is a very common password. And someone is going to try it if they're trying to break into your account using a password list. And if we type something like password, well, we get almost 4 million. and entertaining. I noticed this when I was building my talk. 1, 2, 3, 4, 5, 6 has been seen 24 million times. So these are common passwords. So you want to stop people from using them on your site if you can. But we can't just send them to this random link to type in their password on a random unrelated site because people are lazy and they're not going to do it. Instead, we can use the password rule that comes default in Laravel, and we can add that into our validator and have the password rule, and we can set uncompromised. And we can say that do not allow a password that has been compromised, that is in a data breach, and it uses the pwned passwords API in the background securely to check the password strength and check if it's been breached before. And so you can install this on your registration form, on your change password form, and prevent people from using dodgy passwords, passwords that have been breached, passwords that could be used to break into their accounts. Now, the caveat here is that this is a technical solution, and technical people will get it, but non-technical people might not. And so if your user base aren't technical, if you don't think they're going to understand what a pwned password is, they'll probably try to register for your site, use a dodgy password, and then get rejected. And then they'll go to your competitor because they can sign into your competitor. So you have to take into account of who your users are. And if they're not going to understand what a pwned password is, think about a soft fail. Think about how to check the API and just display a message and encourage them to use a different password, but don't prevent them. Maybe add two-factor authentication, other steps in there, other security measures to keep their account secure, maybe an email magic link to click in order to validate their login or something. So that's topics we don't have time for today, but there are things you need to consider when you've got users that might not understand about the password security. Okay, so we're going to create our own account now. So we're the attacker. We're trying to break into the site. And one thing it would do, whoops, let me type and then talk evilhacker.dev. And yes, that is my domain. It is one of my favorites. Okay, so we're a hacker. We've just created a free account. We're going to look around the site and see what we can do, what abilities we have, what permissions we've got. So this site allows you to encrypt messages. So if I go hello, hi, yay, bye, whoops, nah, it doesn't matter. Okay, so we've encrypted the message and it's given us the encrypted string here. And we can go in here and we can view the message and view the encrypted string. Now, looking at this from a hacker's point of view, something jumps out at me. And we can see here, the new lines have been persisted. Now, if the developer was lazy, there is a chance that in order to get new lines to persist, they have done a string replace or used NLBR, turning new line characters into breaks. And for them to do that, they might have forgotten or disabled escaping of the HTML in order to get it to render correctly. And if that's the case, then we can probably inject JavaScript in here. So let's give it a go. So this is called a cross-site scripting vulnerability. And the way it works is that you can inject JavaScript into a page and then have it executed by the browser when the page loads, either stored in the database or in the URL or something. So hello, new line. I just want new lines in there for later. Hi, and then we've got a script. So this script is going to run what's called the Harlem Shake, which you'll see what it does in a moment. So send that in. We're going to go to the share page, which is something that we can give to anyone to access. To say we can trick one of the administrators of this site to access the page. Let's see what happens. Hopefully the sound's coming through. I'll just mute the sound because it gets annoying. Okay, so as you can see, the page is starting to dance around. So that's the JavaScript that we've just run on this page is now having fun on the page. Now, it's really obvious to us what's going on. Something has taken over the page because everything is dancing. And let me just get away from that. If I can click the link that's dancing under my, there we go, good. So it's really obvious for us to see what's happening there, but what if the JavaScript is running in the background? What if it's creating an administrator account or it's changing settings? You won't notice. So you inject your JavaScript, you get the administrator to run a link on the site to access the page that has the JavaScript. And then you create an administrator account in the background. And that happens all the time on WordPress vulnerabilities. It's a very common thing to do is create an administrator account on WordPress when someone can inject JavaScript. So how do we protect against this? How do we stop this from happening? So let's jump over to the code and we have a look at how messages are rendered. So as I predicted before, because I wrote the code, we can see here that the message is being passed into NL2BR, which is turning new lines into breaks. Then it's rendering it unescaped, which is what these magic curlies do. So what we can do instead, in order to escape the data and prevent the JavaScript from running, is we can use the E function. Whoops, wrong order. So the E function here is Laravel's escaping function, and it's what Laravel uses internally inside the double curlies. And if we pass that in here before a new line to break, or we could use a string replace as well, and then we go back over into the page, we will see now that we've still got our new lines, but it's not executing the JavaScript, it's now escaped it. And so this has protected the output. So you always need to escape user output in order to prevent JavaScript from running or anything like that. So that's one solution to the problem, is to use manual escaping before we convert it. Another trick we can do is we can actually rely on the browser to do the work for us. So if I use the escaping curlies and I get rid of the function, and then I grab a bit of not JavaScript, CSS, sorry, my mistake. Grab a bit of CSS in there, so white space pre-line. We could also use the Tailwind function. I'm just using this for those who aren't familiar with Tailwind. And I refresh that. We now have the fully escaped values being displayed, but we've still got our new lines. And so we've pushed it to the browser. So now we're escaping the output and we're sending it to the browser, and the browser is the one doing the new lines, which means that it's not vulnerable to the cross-site scripting because the browser is handling the new lines as they are. It's not converting anything, not adding any tags. So anytime you can push something to the browser, it's a good idea because the browser has better security than your code. So push if you can, push it to the browser. Like things like this with new lines, try and push as much of that to the browser as possible. Another thing we can push to the browser, and let's just get our vulnerable code back, is we can use what's called a content security policy. And the way that works is it allows us to tell the browser what is allowed to run on our site. Let's jump over to my terminal and make the CSP middleware. Jump back in here. This is our new middleware. And what we want to put in here is our content security policy. So let me grab it. I'm not going to type it by hand because it takes too much memory. Okay, so what we're doing is we're grabbing the response when it's been handled, and then we're passing it into here. We're setting headers set. So we want to set the content security policy header. And our policy, we're using a very strict one for this site. We're saying by default, don't allow anything to happen. So no external information to be loaded, no scripts, no source, etc. But then we're saying allow our own source. So we can have CSS from our domain, but we can't have CSS from anywhere else. And we're also allowing form action self. So submitting forms to ourselves. We can't send data anywhere else. But we have JavaScript completely disabled. We haven't allowed it in this line at all. Which means that when we go back to the page and, oops, just show you again. So we're back to our original code, which we know is vulnerable. But when we go to the page, if I can find it and refresh, it's my content security policies. Oh, anyway, we also need to add it to the kernel. I'd forgotten about that one. Great. So throw that in there, get back to the page, refresh, everything stops dancing. So now our JavaScript isn't being run. We can't see it in there because the browser still sees it as JavaScript because we haven't escaped it, but it's not running. And if we jump over into our console, and I'll just make this a bit bigger, we can see there's a big error in the console that says refuse to execute inline script because it violates the following content security policy directive. And it tells us what's wrong, tells us ways to fix it. We could use the unsafe inline keyword, we could use a hash or a nonce for that specific bit of JavaScript that we've included. But the point is that it's going to block the JavaScript from running. And so this is a backup plan. This is something you set up on your site and you define the rules for what you expect so that if someone does manage to sneak some JavaScript or anything else onto your site, either directly via cross-site scripting, or maybe they've added it onto one of your dependencies. If you're loading a script from a content delivery network or an external provider and they get compromised and then malicious content gets added on those, you can use a CSP to prevent the malicious scripts from being loaded, which will protect your site. So it's definitely a backup plan. You don't want to rely on that to stop cross-site scripting rather than escaping your output. You still want to escape the output, but use a content security policy of backup plan to ensure that if anything gets passed or if there are any other problems, it'll protect you. And we don't really have time to go into more content security policy, but it's something to definitely look into if you're interested in how it works. Okay. Now, as the attacker, we're going to look through the site and see what else we can find, what other things jump out at us. And one of the things that jumps out at me is when you go to the account page, you can probably guess what's happening in the background here, because we've got name and email, which would be 2 fields on the database, right? And if we make a change and we submit, it's going to update with the database. And so it's probably just grabbing the request data and injecting it into the model and telling it to update. Now, because of this, and knowing that this application might be vulnerable or has a lazy developer, we can try and guess at some other fields. So being an admin, a user table, sorry, and user model, a common pattern, and I'm pretty sure, I would guarantee there's at least one person watching this now who has on their user model an admin field that accepts a 0 or a 1 to define if the user is an admin. And so what I can do here is grab a field. So grab the email fields, oops, make that usable again. And I'm going to go to duplicate element, and I'm going to make it an admin, 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 and 1. So what I'm doing now is I've added another field onto this form called admin and value of 1. And I'm going to go save. And suddenly up here, we have the admin link. So we've just made our account an administrator through a vulnerability in the profile page, in the profile update, because it's not protected. So now we're admin, we can do whatever we want. We have full access, game over, right? So why does this work? And as I guessed before, where's my code? Web, great. As I was talking about before, we could guess the code looks something like this, and this is what it is. So we're sending all of the request data that it receives into the update method on the user model. And in this case, the developer would be relying on the mass assignment protection on the model. But the problem is that a different developer working on this site has added admin. So this has probably been added because that developer was working on the admin tools. And so they created, say, an admin creation, admin update method, a user update method, sorry, and they wanted to be able to have a tick box for admin. And they've forgotten that users also have a profile page which does the same method, that users update as well. And so their mass assignment allowance for the admin section is causing a vulnerability in the profile, in the user profile. So how do we fix this? Well, the simplest fix would be to remove admin. And then if we go back in here, let's, because we're a nice, friendly hacker, we're going to remove our admin abilities, or try to. Admin, 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 and then 0. Save that. No, we're still admin, because we've now blocked that field from being filled. But the problem is we've broken the administration section too, the reason why that was added. So that's not actually the solution I recommend. And to tell you the truth, in my applications, I disabled mass assignment protection because I think there is a much better way to deal with it. So if I jump over here, rather than using mass assignment protection with filled and guarded fields, instead, I use a validator on the request. So we'll grab this, oops, and just for the sake of the demo, dump that. Now, rather than doing all, you want to do validate. So in here, required email. And then I'll grab data, do that. So what we're going to do here is send the request data through a validator, which validates the name and the email fields are both required. Then we're going to grab that data and send that into the user update. And the little debug I've got here, so dump will show the raw request data as it comes in. And then the dyn dump will show the request data coming out of the validator. So let's have a look and see what that looks like. Once again, I'm going to make a new input, admin, admin, 0, enter. Oops, that's not what I wanted. I need the other field. Inspect. I have to duplicate it first, and then I make admin, 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 0. Now save. So here we have our dump, which has all the request data. So this is what was being passed into the model. And as we can see, because it was fillable, admin was being set. But the validator only returns the fields that you define in the validator, which in this case is name and email. And so what you do is you use a validator to say the fields that you want to come through. And so every time you accept data from the browser, you validate it and you define every field that you want to accept. then you pass that data to the model. And that way, you know, per request, every single thing the model is receiving. And that means that it doesn't matter what the use case is, what the route does, who can access it. Only the fields that you want to be filled through that route are filled through that route because you validated them. It also gives you the benefit of forcing you to think about the format of the data coming in. So are they required? Do they have to be numbers or strings, or is it a Boolean? And because you're already adding a validator anyway, you're going to think about the types and add validation, which further protects your application from errors and vulnerabilities because you're forcing and checking the type of the data that you're receiving. So that's how I would solve the problem. And that's what I recommend doing, is to use a validator to validate all the incoming data. Okay, so now as a attacker, we're going to, we've decided we're going to break into this site. We want to break into this application, and we can figure out, if we figure out, say it's Laravel, we can have a look for known vulnerabilities in Laravel and see if there's anything we could exploit. So back in, sorry, one sec. Back in July last year, there was a security release for Laravel cookie securities, the cookie security. And reading the release notes about the security vulnerability that was patched in July, down in this paragraph down here, this line, I'll read it to you. So regarding the vulnerability, applications using the cookie session driver that were also exposing an encryption oracle via their application were vulnerable to remote code execution. So let's look through the key bits. So cookie session driver. That means that the session information is stored in the cookie, and that's easy to check. We can just go to the application and look at the cookie value and see if it's this huge encrypted string. The second thing it says is encryption oracle. Now, encryption oracle is where you can pass in plain text and get an encrypted value, which is exactly what our site does. And the third bit, and the bit that jumps out to you as a hacker, jumps out to you as someone who's trying to compromise the site, is remote code execution. That means that as the hacker, I can run my code on that site. And if I can run my code on that site, I have full access to do whatever I want. So if the site is vulnerable to this vulnerability, we can break in and we can have full access to the site by exploiting this. So we can check if it's vulnerable to, if it has the cookie, and it does. We can see the cookie value here is quite long. So that means we've got cookie session data. So what we can do then is generate our own cookie and get that to break into the site. So I'm trying to think if it's mentioned here, it doesn't matter. Okay, so the way this would work, and because it's remote code execution, that suggests the problem is a deserialization attack. That means that PHP users can serialize objects. You can serialize any bit of data that it has stored into a string, so you can store that. You can encrypt it and store it somewhere and send it around. And then it deserializes that and turns it back into an object. And if you can hijack that value, you can generate your own classes. And if you can generate your own classes, you can run your own code if you can find the right class to call. And that's where PHP GGC comes in, which is PHP generic gadget chains. And this is a tool for building a payload for unserialized that allows you to run your own PHP code. And it has a bunch of different chains for different applications. There's a whole pile of Laravel ones in here. We've got Monologue, Swift Mailer, Symfony, WordPress, etc. And so we can use this tool to generate a gadget chain to compromise this site. So I'll jump over to Tinker. And I will grab our payload. So what we're going to do is we're going to use the PHP GGC tool and the Laravel RC6 to run this exec command in here. And that's going to package that up as a serialized string. So we can see it's a big long string now. And it starts off with the O telling us an object. So we're using the message bag class, we've got pending broadcast, and eval loader, and a few others. And eval loader, I believe, is the key here because it allows you to run PHP code. It allows the PHP code to be evaluated and executed. And if all of these classes tied up together, when they're deserialized, we'll trigger that code. So now we've got our string. We want to turn it into a cookie, something that Laravel will recognize, a session string, sorry. And so we can encode that as data with an expiry date, which is the format that's required by this version. And this gives us the raw string that we want to give to the application in order for it to try and revive the session from the cookie. So we'll grab that, throw that over to our, where's it gone? I can't find it, there we go. Throw that over to our site, and we're going to go here and encrypt it. And this now gives us the cookie value. Now, the other thing we need to do is start a listener. So what we're actually going to get this working is a remote shell, a remote connection back to my hacking box, my Kali box. And now we're listening to any incoming connections on port 1234. We'll jump back to the site. We'll grab the cookie value, copy in here, and we'll replace the current cookie session value with our own session, fake session value. Click enter. Then I'm going to click enter on that. It's going to load. I'll jump over to my code, to my terminal, and suddenly I have a remote shell into the application. So that's the public directory. Oops, I can't type. That is the main directory of the application. You might recognize standard Laravel features in there. We've got access, full access to the code. We can go cat env and find out what's in the environment file. We can access anything else that is on this server. We can also look for misconfigurations on the server. For example, does sudo have a password? Is the user allowed to run sudo? Yes, they are. We now have full root access on the server that this application is running on because I haven't protected the account and because we were able to get remote code execution. It's game over. There's no way around this. There's no way out of this. We now have full access to the site. We can do whatever we want. And there's nothing that the developer can do about it once we're in. We can add whatever we want, especially with sudo access. And it was that simple. I showed you every single step I did to get straight into this application that had the configuration and the vulnerable code. So how do you prevent against this sort of an attack? And the first and most obvious one is to keep Laravel updated, keep all of your packages updated. Anytime there's a security update, any security releases, apply them immediately. Some of them might not apply to your site. In this case, there was a very specific scenario that was needed in order to make it work, but that's not always the case. Sometimes there are really simple vulnerabilities that affect everyone that get patched and picked up quite quickly. But if you haven't updated your site, then you're still vulnerable to it. And so keep things updated. And the other thing that would have saved this site is the encryption key. So it used the standard application encryption key for everything, which means that we were able to spoof and generate our own cookie value. But if the application was using a different encryption key for the encryption oracle, for the messages that the user was encrypting, then we couldn't have spoofed the cookie session. We couldn't have faked anything. And so we wouldn't have worked because it relied on us being able to generate our fake session and for the application to decrypt it. So anytime you're using encryption keys or doing any sort of encryption, don't use the application key. Generate a different key and use that instead. And so it doesn't matter what we can do with the encryption key that we've got access to, because it won't allow us to modify any of the system, any of the application encrypted things like the session and such. And that's a really important thing to remember. Anytime you're doing anything with sort of encryption and keys and things, is to always use a separate key. If you can, do a separate key per user. That will ensure that it doesn't matter, if this key for this user is compromised, or the key for that user might not be compromised, etc. And it means you can't spoof messages between users, and there's a whole bunch of extra protections you'd get in place from that. So I think that about wraps it up. So thank you very much for listening. I hope you learned a lot and that this helps you to get into the mindset of a hacker and to look at your applications and think about how you can protect your sites and protect your apps and what areas that need your focus and need priority work. So you can find talk notes on my site there on the top link. If you want more information about any of the things that I've looked at, or feel free to send me an email or find me on Twitter if you've got any questions, anything you'd like me to answer better, go into more depth on, and check out Laravel Security in Depth, which is an emailing list that I've set up. So thank you very much for that.
Awesome. Great job. Very interesting stuff, obviously, stuff we don't all spend necessarily that much time on in our day-to-day kind of coding regular things. So always good to see that from the other side.